In this presentation, we will discuss what is the difference between latch and a flip-flop. So, for this, let us consider the circuit which is shown in the figure. From this figure, we see that the circuit shown in orange is a very familiar circuit which we have already discussed. This is our SR latch. We find that there is no control input given to this circuit, and in this case, when there is no controlled input given to this circuit, then the values of S star and R star can be changed accidentally or intentionally. Therefore, this circuit is not suitable for use. So, we need to introduce a control input to this circuit, and so for that purpose we have added two NAND gates to this circuit. The output of this NAND gate is input to this NAND gate. Similarly, the output of this NAND gate is input to this NAND gate. Now, these two NAND gates has two inputs each. One of the inputs to this NAND gate is S and one of the inputs to this NAND gate is R, and there is a common input to both of these gates which is known as the controlled input. Now, this circuit can be used as a latch as well as a flip-flop. So, let us see how we can use this circuit as the latch. The only thing which decides whether this circuit is working as a latch or a flip-flop is this controlled input. If this control input is not a clock but it is just enable, then this circuit will work as a latch. That is, when enable is high, then the latch will operate. So, when it is enable, it means that it is level triggered. That is, it is sensitive to level triggering. It means that when enable will be high, then this circuit will operate. So, we have drawn an enable signal here. This is a random enable signal. So, this circuit will be operational only when the enable is high. So, the circuit will be operational for this period, for this period and for this period. That is, whenever the enable is high, then this circuit will be operational, and the circuit will not be operational when the enable is low. That is, when for this period, for this period, for this period and for this period, the circuit will not be operational. So, whenever this is the case, that is, whenever the enable is high, then this latch will be operational. Now, let us see what happens in the case of a flip-flop. So, before explaining flip-flop, let me explain you why the circuit is operational when the enable is high. So, if we write the value of S star, it will come out to be S complement plus En complement, and similarly R star will be equal to R complement plus En complement. So, if enable is high, then if enable is high, that is, if enable is 1, then this value will be equal to 0, and so in that case the value of S star will be equal to complement of S, and when enable will be equal to 0, then the value of S star will be 1, and similarly the value of R star will also be equal to 1. That is, in that case we will get the memory. So, we find that when enable is given as the input to both of these NAND gates, and whenever this is a SR latch with NAND gates, then if the value of S star and R star both are equal to 1, then the output we are going to get will be the memory, that is the previous state. So, whatever be the value or the state stored in this latch is stored until we change the value of enable signal, that is En. That is why we call it as SR latch with controlled input. So, this is the working for the latch. So, whenever there is enable then signal, then we will call that circuit as latch. Now let us see when this circuit will work as a flip-flop. It will act as a flip-flop if we are having clock in place of enable. And we know that what is a clock? A clock signal is somewhat like this, and the duty cycle for the clock is 50%. So this is the clock. So when we say that it is a flip-flop, it means that there will be triggering whenever there is edge triggering. That is, whenever the clock pulse goes from low to high or from high to low, during this period only this circuit is operational, and in that case we call it as flip-flop. That is, whenever this clock pulse will go from low to high or from high to low, then during that period only this circuit will be operational, and in that case we will call this circuit a flip-flop. So at last we derive at the conclusion that the latch is level sensitive, whereas the flip-flop is edge triggered. So according to the definition, we can define the latch and the flip-flop as: latch and flip-flops are the basic elements of any sequential circuits, and these are used to store information. One flip-flop or latch can store 1 bit of data. The main difference between the latch and the flip-flop is that a latch checks the input continuously and changes the output whenever there is a change in input, but flip-flop is a combination of latch and a clock that continuously checks its inputs and changes its output correspondingly only at times determined by the clock signal. And we know that a latch is level triggered, whereas a flip-flop is edge triggered. So we find that we can call it as a flip-flop. Then it will check for the input, and the circuit will be operational only when the clock is changing from high to low or from low to high. So this is the difference between latch and the flip-flop. I hope you have understood the difference. So that's all in this presentation. See you in the next one.